All right. So we're going to talk about basic probabilities and independent events. And there's not really going to be a ton of structure to this because uh, it's not super rigorous, but it's a little bit tough to comprehend sometimes. And so I just want to chat about it. I want to look at some examples, and then there'll be a Google form for you guys to do some practice questions. This is one of those things that in life it's nice to understand probabilities and the chances of things happening, um, just for generally being well informed as an adult human, right? Um, so some of the classic examples you'll see is rolling a dice, or they like the questions like, oh, there's a jar and there's um, 27 different colored balls in there, and what are the chances you pick out a red ball and then a green ball, right? Or questions about decks of cards, and the decks of cards ones are a little bit more difficult because I don't know how many of you guys are playing cards regularly or know what all goes on in a deck of cards, but those are frequently used. Or multiple choice tests, and there'll be questions of each of those types on the form. But that's just a small sample size of a ton of different options, right? And so, um, what do I mean by probability? Well, it's the chances that something is going to happen. Okay. So, uh, you know, uh, let's say that I go outside, right? What are the chances that it is sunny or it's not sunny, right? And there's a lot of different factors that goes into that, but there's two probabilities, and until I go outside, then the probabilities are king. But once I go outside, obviously it's either sunny or it's not, right? And so it's the same with many events, right? I can roll a dice, and I might say, oh, well, there's a 1 in 6 chance that I roll a 3, right? But if I roll a 3, then there's a 100% chance that I just rolled a 3, okay? And so when we look at probabilities, we're looking at the probabilities that something could happen. We're not looking at the probabilities that something um, did happen, right? Because once something does happen, it either did happen or it didn't, and that's not as interesting to look at, right? And what do I mean by independent events? Well, events that don't affect each other, right? So if I roll a dice and I get a 3, that doesn't affect what the next dice roll is going to be. Maybe I roll a 3 again, and that's maybe mildly surprising, and I roll a 3 again, and that's mildly surprising, but each of those times I had a 1 in 6 chance of rolling a 3, right? Those are each independent events. Me rolling a 3 one time doesn't affect me rolling a 3 the next time, okay? And so these are the easiest way to deal with events. It gets more complicated when events affect each other, okay? Um, and we'll discuss that a tiny bit because there are some independent events where what you do previously affects it, but it doesn't change the fact that it's an independent event. And so that's something you'll see with like card decks or with the jar and with all the balls in it, something like that, right? So um, just off the bat, let's look at a dice, right? So a regular dice has 6 sides numbered 1 through 6, right? And so there's our little dice. Let's see how well I can draw one. Right, and so this side, maybe there's 3, and that's the one side, and then 6. Okay, and so the first thing that I might ask you is, what's the probability of me rolling an odd number, right? Well, I can roll 1, 2, 3, a 4, a 5, or a 6. Okay, what are the odd numbers? 1's odd, 3's odd, 5's odd. So I could, if I roll an odd number, then there's a 3 in 6 chance, which I can simplify to 1/2, right? So if I roll a dice, there's a 50% chance that I roll an odd number, which also means there's a 50% chance that I roll an even number, okay? I could also say, what are the chances that I roll numbers that add up to 7 on 2 consecutive rolls? Well, that one might be a little complicated at the moment. What are the chances I roll any one of these numbers though, right? Rolling a 1, there's a 1 in 6 chance. A 2, there's a 1 in 6 chance. 3, there's a 1 in 6 chance. Where we get into independent events is when we combine two events. Okay, so instead I might ask the question, what are the chances that I would roll first an odd number and then I roll a 6? All right, so we already know that the chances of me rolling an odd number are 1 and 2, 1/2. The chances of me rolling a 6, 1 out of 6. And if they're independent, then I just multiply the probabilities together. If independent. Okay. And this is super nice, but the key here is that it has to be independent, right? So me rolling an odd number does not affect me rolling a 6. So the probability of me rolling an odd number and a 6 on 2 consecutive rolls is 1/2 times 1/6, or a 1 in 12 chance, right? Another favorite is what are the chances that I roll 2 dice, okay? And for example, they add up to 7, okay? Well, let's look at all of our numbers. What can add up to 7? Well, we could have 1 and 6, or we could have 6 and 1. So we've got 2 already, right? I could have 2 and 5, or I could add 5 and 2. That's another 2. I could have 4 and 3, or I could have 3 and 4. That's another 2. Okay, so this one's a little bit trickier, but essentially I could roll. It's not necessarily a good way to go about this, right? But between two rolls, I could roll any combination of 36 different numbers, right? Because when I roll a dice, I have a 1 in 6 chance of getting any particular number, and I'm rolling it twice, so a 1 in 6 chance, which should be 1 out of 36. And I already decided that there are 6 combinations that'll give me a 7. So if I wanted to roll the dice and add them up to 7, well then I have a 6 out of 36 chance, or a 1 in 6 chance of rolling 7. And if you look into it, when you roll 2 dice, your highest likelihood, you have a 1 in 6 chance that you'll roll something that adds up to 7, right? So if you've played something like Settlers of Catan, hopefully you'll realize that the robber is actually meant to be frequently moving around, because that is supposed to happen potentially about 1 every 6 turns. Okay, and so it's kind of a fun little application there, right? Really, what I would, that's maybe a little bit above. I would love for you guys to be able to understand having 2 independent events and just multiplying them together, right? So let's look at one more with dice, and then we'll try something else. So what are the chances that I roll a number that is divisible by 2? Okay, 3. So what numbers are divisible by 2? Well, 2 is divisible by 2, 4 is divisible by 2, 6 is divisible by 2, right? That's also just the definition of an even number, but divisible by 2, I've got 3 out of 6, or 1/2. And then we could say, if I roll it again, what are the chances? What would be an interesting one? What are the chances that I don't know. We'll just say, what are the chances I roll an odd, right? So I already rolled an even. What are the chances I roll an odd? That would be 1, 3, and 5. Odd. Once again, 3 out of 6, or 1/2. Well, 1/2 times 1/2 is 1/4. So there's a 1 in 4 chance that I roll an even number and an odd number if I rolled 2 dice. Okay? Hopefully it's pretty obvious to you that one dice roll does not affect the next dice roll. Unless I guess on the first dice roll, you somehow damaged the die, right? And then, in which case it would be perhaps a strange scenario there. Okay? Now let's look at something like, so let's say I've got a jar of balls and I've got 2 red, 3 blue, and 1 green. 2 green, 2 green. Okay. Now the chances that on one pick I pick any of, so if chances I pick a red ball, well, 2 out of a total of 7 balls, 2 out of 7. If I chances I pick a blue, 3 out of 7. Chances I pick a green, 2 out of 7. Okay. Where it gets interesting is if we look at multiple probabilities, right? Independent events. Okay. So event 1, I pull a red ball. Chances that I pull a red ball. Well, chances that I pull a red ball are 2 out of 7. Okay. Now you might be saying to yourself, well, if you pull out a red ball, 1, now you only have 1 red ball left in the jar. 2, now you only have 6 total balls left in the jar, right? That's where these events are connected. But after I pull out 1 ball, all it does is affect the probabilities of the others, and we can adjust that by just saying, well, now there's 6 balls left, right? Now there's only 1 red ball, okay? And so now the chances become 1 out of 6, 3 out of 6, and 2 out of 6. All right, so now the chances that I select a green ball second would be 2 out of 6. This one, order is important, right? If I selected green first and then red, or blue first and then red, it would change a little bit. But now the chances that I selected a red and then a green are 2 over 7 times 2 over 6, which would be 4 over 42, or 2 over 21. All right. And you could continue going on. You could say, okay, what are the chances I pick a blue next, right? And well, now there's 5 balls left, but I still have 3 greens because I haven't pulled any out. So that would be 3 out of 5. And then you would just multiply all those together. So you can multiply more than 2 independent events together. 2 is just most easy to keep track of. Okay. There's a similar idea with a deck of cards. The deck of cards. Okay. If I want, what are the chances that I pull a red 4? Well, there's 52 cards total, and there are 4 4s, but only 2 of them are red, so I have a 2 in 54 chance, or 2 out of 52, sorry. Okay, well, now I've pulled 1 card out of the deck, so there's only 51 cards left, right? And let's say now I want to pull out a queen, right? So I pulled out a red 4. Now there are only 3 4s in the deck, or 51 total cards, but there's still 4 queens, so I have a 4 in 51 chance, right? Now if I want the probability of those two, well, 4 times 2 is 6, and 52 times 51 is 26. 52. We could divide both of those by 2, which would give me 3. And 13, 26. Okay, and those are pretty long odds. That's pretty unlikely to happen, right? And so now you can see why games like blackjack and poker are, it's meant to take your money. The casino has the upper hand because the casino wins if you don't. So the casino has 13 323 chances to win, or options or ways that they can win, and you only have 3 ways that you can win if this were a way to win a game, right? Maybe you're playing poker and you're trying to get 2 pair, right? And so you need a 4 and a queen, or maybe that wouldn't exactly work. But you guys can see how the skew is towards the house. It's a lot more likely that they'll win. Okay, so these are both independent events. The only difference is we have to adjust that second probability with how many chances are, because we're pulling something out. Now let's say that you pull out a red 4 and then you put the red 4 back in the deck and you're going to pull out a card again. Well, then nothing changes, right? It would be out of 52 or 52 again, and that's fine. But you do have, generally, I would assume if you're pulling a card out, you're not putting that card back in. Or if you're pulling a ball out of the jar, you're not putting that ball back in for the second draw. Okay. So I think I'm going to conclude the video there. If you would like more help, or perhaps another example, something like that, send me an email. But I think that is where we'll conclude it, in the interest of keeping this video relatively short.